Hi, my name is Anurag. In this short presentation, I'll talk about system reliability. In the next few minutes, we will see the different techniques that are used to build systems that are resilient. Reliability is the assurance that a system will continue to work without any problem when in operation. Achieving reliability for a standalone system like mobile apps or desktop apps is not a hard issue. It is, however, a very significant challenge for large scale systems, particularly the distributed ones. The reason is that they suffer from partial failures unlike a standalone system. Let's see what do we mean by partial failures. A partial failure is the failure of a component of a system while majority of other components are still running fine. The system now as a whole should either replace these faulty components with healthy ones or it should know how to work in the absence of the failed components. In a large scale distributed application, anything can fail. It can be a machine failure due to a faulty CPU or a faulty hard disk. It can be a network. It can also be an entire data center. Availability is another important property of a system. It is a measure of how long a system is available for operations. Even highly reliable systems can become unavailable for repairs and upgrades. It is the availability property of a system that guarantees that the system will be available for operations. As an example, a system that has 99.9% availability cannot have a total downtime of more than 8.7 hours in a year. In order to ensure reliability and availability properties of a system, we need to make it fault tolerant, which is making a system resilient to failures. It should be able to detect failures and should be able to recover from them during the operation itself without affecting the quality and safety of operations. A typical fault-tolerant design has three standard procedures. First, it has a provision for redundancy. Second, it has a provision for detecting faults. Third, once faults are detected, it has a provision to automatically perform the recovery. Let's see them one by one. Redundancy of a component is the presence of a secondary capacity which can perform the entire operation of the primary component on its own when the primary capacity becomes unavailable. A redundancy can be of different types depending upon how quick it can take over. An active redundancy is always in operations along with the primary. The takeover from the primary is immediate. For example, a synchronously replicated database instance can quickly take over the primary database instance as soon as the primary goes down. A passive redundancy is not active but is kept ready for a quick takeover. For example, an asynchronously replicated database cannot take over quickly from the primary. It has to first catch up with the transactions that were relayed by the primary instance but did not take place in the secondary instance. The takeover is somewhat delayed. Once a fault occurs, it has to be quickly detected. There are broadly two ways to do that. First is monitoring, and the second one is heartbeats. Monitoring, which is also known as health checks, is a process of monitoring the health of a component by an external monitoring component. Monitoring component itself needs to be a highly reliable and available component as it can itself become a single point of failure. The other mechanism is called heartbeats. It is similar to monitoring, but the difference here is that the monitoring is performed by peer components which monitor each other. All pair components broadcast their heartbeats at regular intervals. If one of the components is missing for a long time, it is declared as dead and the other pair component takes over. This slide brings us to the last step called recovery. Once a fault is detected and a component is declared unhealthy, it should be quickly replaced by other healthy redundant component. This process is called failover. Failover is a very simple process in case of stateless components. For stateful components, this process is little more involved. A stateful component requires regular backup of its state called checkpointing, which happens along with the logging of all transactions to a log called write ahead log. The failover process involves resurrecting a secondary redundant component using the latest checkpoint followed by the execution of non-executed transactions in the write ahead log. There are some other ways too for recovering depending upon the type of a failure. If a failure is transient, we can retry the failed request. In another case, if the system cannot repair itself and the loss of a component is non-critical, the system should know how to function without the non-essential component. For example, an online booking system can functionally always function in the absence of a recommendation system. We should ensure through design and testing that it is indeed the case. As a best practice, all recovery processes should be tested regularly by deliberate introduction of faults. Any redundancy that is not tested regularly cannot be relied upon as system state is always dynamic and moving. This was a very high level view of system reliability. I hope that you found it useful. If you wish to learn more, please go to our website newtechways.com and check out our course on software architecture. If you liked this presentation, please do not forget to share it with others. Thanks for watching. Have a great day.